I'm just getting my food prepped before we begin. That's all that's happening. Gulag session? No, because we enjoy working hard. We enjoy getting stuff done. That's why we're doing this. You will get a camera. We will power on the camera in a second. I accidentally left it on all day and just realized that at the start of the stream. So I'm giving it a few minutes at least to cool off. It rarely overheats, but once it did when I left it on for like 18 hours or something. So we're just minimizing that. The internet told you it is bad to work hard on things. I know. I know the internet says that. We'll probably start in about 5 minutes. The tea is steeping and I'm eating a food prior to start. Before starting a session that makes a big change to your code, do you still have that where to begin stage, or is that passed with experience? Most of the time, I'm not that worried about where to begin. Sometimes I'm a little worried if my beginning point is going to lead to the right ending point. But I always feel like it's better to just go than to be paralyzed by not knowing what to do. Sometimes I don't know where to begin, but it's pretty rare. It's pretty rare. And even then, I can do something. Like, if I don't really know what to do to start in an ordered manner, I'll just play around with things, you know. One of your professors claimed to have invented bytecode. The guy's a jackass then. Like CPUs run bytecode. That's what instructions are. All bytecode means is pretend CPU instructions. That are running in software instead of a CPU. And like people have been doing that since the start of computers. All right. Now he may lay claim to some more specific thing that either he's not emphasizing or you didn't remember, but saying that you invented a bytecode is I mean jackass in a bad way though. Like I mean, not smart, jackass. If someone is saying they invented byte, like if you claim, like if something is super obvious, but you go around claiming you invented it, even if you were the first person to do it, if it's super obvious, it's just like, bro, get it together. Why would you run those instructions on software instead of directly on the CPU? Because you want to run different instructions than the ones on the CPU. Really, though, computers is kind of full of people who are claiming that they invented things that were actually obvious, right? So it's not that surprising when people do it, but still, it's annoying. Like, if people would stop doing that, maybe we could actually get serious and make computers good, you know? All right, so now I have a problem. I'm trying to get ready to start the session. I don't know where my wireless mouse transmitter went. Oh, there it is. Okay, we good. We good. Apollo landing computer had actual bytecode running. Yeah, I'm not surprised at that at all. Like the inventors of computers did not differentiate as much between levels of things as we do now. Like part of what happened as computer science codified is people had to come up with all these classifications and rules and categorizations so that they could seem important. And that's when a lot of terminology was born for things that are really simple, actually. There's actually an anecdote about this in The Dream Machine, which this is me reading between the lines, and I certainly wasn't there. But there's this drama in there between two guys who claim they invented machine code instructions, right? And Norbert Wiener, who they say, or Wiener, I guess, because he's not really German. I keep saying Wiener because I kept assuming he was German because his name was so silly, but no, he was American. Anyway, Norbert Wiener talked to them about it, but my assumption is that he thought that idea was obvious for years, right? And they, being lower on the smarty person tree, thought it was an amazing idea that nobody had thought of. And so they blamed him later for taking their idea or something, when he probably thought it was one of a million just like obvious things that you obviously would do with a computer, right? So I don't know, like people who go around making claims like that I've learned to stay away from them. If we remove the insane cost of university, are there any places where you'd think, yeah, that's actually worth going to? I mean, relative to what? Relative to not learning anything? Yeah, you could do Berkeley or CMU or Stanford. Relative to what you could do, no. You would be much better off learning intensely on your own, like doing a Teal Fellowship kind of thing, than you would be going to any school. I think Peter Thiel is exactly right about that. All right, we're going to get started. He was making fun of Java about some claims about the JVM being impressive. Yeah, that's fine, but he also didn't invent bytecode. Like, let's be clear. All right, I'm putting away chat, and we're going to start the timer. I need to get an on-screen timer, but we do not have one at this time. Lol. Okay, okay, hold on. The text here is like, needs to go left because it's on the Emacs background. We're just going to leave it off center. All right, goodbye, everybody. I have a 5-minute break because I learned about that from last time, but I will not be reading chat during the break either. I'm just going to have a 5-minute break and then start another 90-minute timer. I will occasionally narrate what I am doing, but I might not. If I get really focused, I might just be quiet. But my goal is to get a lot done. Hopefully, I can end with a running system that just needs features added, right? But we'll see. Let me, before I start the timer, let me just make sure everything's building and running. Oh, haha. Oh, let's celebrate, by the way, for people who haven't seen this. The compile time execution has been mostly good the whole time. But you know, it's always had one or two little flaws. But now, so this run main is in main of the Sokoban game. So if I'm hitting F7 to compile the Sokoban game right now. It takes a little longer to start. You can see it's loading things. It's loading shaders and stuff. It's slower than native execution, as you would expect. But here we go. It's the entire Sokoban game. Every time I stop to load a shader, it hitches, so it's being... but, you know, the normal frame rate is around 20 right now. If I'm not loading animations. I need to speed up the animation loader. But anyway, that's loading the teleported animation. Here we go. So this is all running inside the compiler in compile time execution, which is pretty good, I think. I'm happy with it. I am happy with it. I also have my snacks lined up. Oh, I can also, let's try opening the editor. Here's the editor. You can see the frame rate's a little low as I drag windows around, but this is good because we can use this as a benchmark of compile time execution, that we speed it up and stuff. But like, I can edit levels in the compiler, guys. All right, enough of that. Ready? Okay, so again, I'm about to close chat. I'm not going to see if the stream Fs, I won't see, although it might not, since I realized I had killer network drivers on this machine and shut them off. We'll see. I want to adjust the temperature. We'll see. All right. everybody. Oh, and I'll say the last thing is my goal is to make a debugger for compile time execution. Right now, you know, if you compile a target program, you have a machine code program, and that can be debugged in your debugger of choice, whether that be LLDB or you know, Visual Studio or whatever. But when you have a meta program that's being built in the compiler, you don't really have a good way to know what the hell is going on. And so I want to build a system that at least gives me, for today, the target is to have some kind of minimal bytecode level debugger where it draws the bytecode instruction and shows values and stuff like that, right? And assuming that goes well, we can expand it from there. But that's going to involve having a little interactive debugger where I can type commands into, having like being able to print out bytecode instructions, having ways of signaling that we should drop into the debugger, and all sorts of things. So with that, I'm going to start it, and I'll see you guys in 3 hours. Here we go. Timer is go. Chat is closed. Okay, so the first thing I want to do is make a command in compiler that you can call at compile time that just says break into the debugger, right? And yeah, let's just, now this is confusing because we have a debug break intrinsic, and I wanted to call it debug. We'll call it like compile time execution break or something. All right. So compile time execution break. You know what? We could put it here. All right. So we've got to make this do a thing. That's my first goal, is to just make this happen, and it'll just printf something for now, and we'll make sure that it printfs something, and then we'll make that thing be useful. So I'm going to look for debug break. That's not there. Oh, because intrinsics work differently. All right. Intrinsics, we actually do string compares in bytecode builder. Oh. Yes, okay. Okay, what should I even do? I guess I'll output a debug break instruction. Wait, maybe we should make debug break. Maybe debug break should just... Yeah, let's just overload debug break. Never mind. Oh. This actually stops things if we're running the debugger on the compiler. Don't totally care. All right, we're going to overload this for now. Or not overload. We're going to change what it does. Okay. So stalled makes me sort of stop. We're going to have interactive debugger. Okay, interactive debugging. All right. Oh yeah. So we have this if thread stalled. Oh, did I commit my earlier changes, guys? I did a bunch of stuff today. Oh my goodness. Guys. I didn't commit all my other things. We're going to have to do that. Hold on. Hold on. Let's verify that nothing is too broken. Oh, let's not do that. Or actually, let's do that. Okay, fine. And then we'll run the tests. And another shell. It's probably fine. It's fine. All right. No. Come on. Come on. Okay. I see why I wanted to attack that, but I don't care right now. Okay. Great. So, if we're stalled, we break if thread interactive debugging, then, so we're always going to run one instruction if we're stalled. So if we're stalled with interactive debugging, we're going to say, this is a weird one. Because we actually need to handle stalls. That's going to be annoying. Okay. Otherwise, go to the debugger. Okay. If the thread is not stalled on Lambda, or this is kind of stupid, but we always set one of these. We're going to print cowabunga, and then we're going to go to loop. Okay. So that's happening. And then when we go to loop, we just get the call record again and all these things. If we're stalled, Oh my goodness. We are not handling stalls correctly right now. I note. Because we need to set resume. Okay. So we do that. We cowabunga. So if we see cowabunga, oh, look, it ran. Okay. So if we see cowabunga, it means that we went to the debugger. Now we need a program to do this. Let's just make one. Import basic, print hello, print goodbye sailor. X is 1 plus 2, y is x times 3, z is factorial of y, print z is whatever. Factorial, we'll do an iterative factorial. Product is 1, product times equals x, x minus equals 1, return product. Okay, so that's great. That is our program. There's no debug break in this program, so if we run it, oh, you know, we don't have any compile time execution, so let's do that. We're going to run main while we compile it. Great. Hello, 362.880, goodbye, sailor. Excellent. Now what? We want to want a debug break. Let's put a debug break here. Not fernet, debug break intrinsic. All right. So now we're cowabungaing, but the problem is we're not finishing with the procedure. Right? So if I do this, what's it called? Record. So what's going on there? Oh, we don't do the index. Okay. Okay, now we really screwed something up. Why? Let's see what it is. Let's just see what it is. Address was null pointer, no surprise. Okay. So I screwed something up. Well, you know what we can do to debug this? is to start doing the things like we want to do. Next PC is thread current block first instruction index plus record resume PC index. Record current block. Now, is record is down here. And we don't change record if we stall. All right. Then we current block instructions record resume PC index, right? Is that a thing? Current block is not. What is it called? Bucket. Okay, so now we have a printing thing. So we're going to say bytecode record bytecode BC instruction index is next PC, right? Okay, so we need a printer. So we already have this disassembly because of the dump that we do. Oh, it's in this file. No, it's not in this file. Wait, what? It is in Bytecode Builder. Okay. So we don't have this for one. See, all this basic block stuff could be useful too. I'll worry about that later. So what we want to do is do an instruction range. Okay. We'll just do this. Print single instruction. And then do this. Do that and that and that and that. Print single instruction printer bytecode, or no, interp bytecode BC instruction index concatenator C auto S equals C dot get result defer free S. And then we're just going to printf it. Like, yeah, we could do that more simply. Okay. So now it's still not going to work because we didn't fix the problem. Oh, also we're making the debug compiler right now. That's great. We're running the release compiler. Super good. Okay. So here we go. We are printing out the instructions. So after the debug break, we do some things. We do a constant in imul. We call factorial. We copy. We do a constant. We jump. We bin up. We copy. We add int. Copy. Return. So after returning, we frickin' die. Why is that? Returning usually works. Like if we don't debug break, this works fine. I believe. Let's try it. I mean, we might have broken that. So if we don't debug break, nope, it works fine. So what about the return? Oh, well, we're stalled. We are stalled. Okay, all this stuff is going to be hosed, actually. Dang it. This loop is very inconvenient because we want to break here if we are legit stalled. And we want to break down here if we are not legit stalled. Wait. No. If we are legit stalled... Okay, stalls are not going to happen that much. Okay, so basically, so this part is even probably mostly fine, right? Actually, I think this set initial bucket is redundant now because this gets called by push procedure, which probably gets called no. Okay. Anyway, when we put this record here, we can do this. I mean, actually, if new record, even if new record is equal to record, we can go to loop, right? Right? New record might be equal to, the record might not have changed if we are an intrinsic, if we called, not bald, called an intrinsic or something. If so, just take the hit and jump to the start of the loop. Okay, because, okay, let's just, right? So if you execute a call, just go to, I'm trying to simplify this because then I want to look at how to work the debugger stall in there. All right. Dang it. Really? I guess we're calling it too soon. Oh yeah, we're calling it too soon. It's like when comedians make jokes that are too soon. Okay, that's probably better. Nope. What is going on, bro? Dude, Visual Studio sucks so bad. Oh, wait. Actually, in this case, that symbol may not actually be in scope. Lol. I'm just so used to it going out of scope. Okay, we actually have it here. Known lambda, get std handle. Okay, that's foreign. Okay, rather than think about all the different cases, we're going to go we're just going to only do it if there's code there. Still. Oh my goodness, guys. What is the... Oh, yeah, okay. I assumed that we always had bytecode, but I guess that's not true. Because like the bytecode has information about some other things. All right, great. Now we're back to crashing on the return, which is what we expect because we didn't try to solve that problem yet. But we're going forward. And yeah. So when we return, oh, you know, if we're interactive debugging, we're going to want to print stuff like when you go into another function and when you leave another function. That's disorienting because this is going to be a command line debugger. We're not doing a graphical debugger today. We may do one at some point. For now, we're just doing a GDB-like thing. So, we're going to want, if we're stalled, we're going to want to go through, we're going to want to know that fact in return and stuff anyway. Okay. We'll rename this later. If it's an actual stall, we break, okay? Otherwise, okay. So I want to avoid I want to avoid adding another if statement to this loop at the bottom because it runs for everybody. Yeah. Okay. Yeah, so I'm just going to enumerate these cases below, and all of these cases are going to branch to the right place. You know what? We can even do this, I believe. Okay. If not, record jump to block is less than 0, or BC instruction is equal to bytecode call procedure, or BC instruction is bytecode return. We will be able to do something better here later, but if not that, we do this. Okay. Otherwise, okay. Okay. And this is, again, fine because we actually want to do stuff here. We want to tell you that we called or returned. Oh, yeah, is an actual stall. Oh. If it's stalled and it's not an actual stall, what does that mean? Well, again, this is all going to get renamed and refactored later, so I'm not worrying that much about it. Okay. 2817. Okay, great. Syntax error, curly brace. What did I? Oh, because I got rid of one there. Yes. There. What? Okay. Well, we're still crashing on return. That's fine. Let's actually because like I said, we're going to want to do something else later. And we're going to want to do that also when we call things. Okay. Actually, we want to re-get record. Cannot type. I don't think that's going to fix anything, but I might. Printf, press F for print. Okay, so now we do the return. Now we say next instruction PC11. Why are we saying that? Because the return should have, okay. Let's do this. Because we're not worried about nesting this super deeply, because actually we're going to call out to some debugger file. Okay, so wait, why are we? That was an old compiler, because we're not cowabungaing anymore. So we're still, after the return instruction, we're still trying to print PC11, which doesn't make any sense. Oh, actually, yeah, no, this is totally jacked. We don't, so this incrementing, this might not be the only problem, but this incrementing the index assumes that we came from here and not any of these other places. So that's bad, first of all. Okay. Okay. Okay, so going to do these. Here we already set them no matter what. Here we don't set them. Wait. No, but we don't want to do that there. Okay. There we go. Except now we're running longer, but we're infinite looping in a way that we shouldn't. We're going 4, 5, 6, and then we're returning, and we're going to line 4. That doesn't sound good. How did I mess this up so badly? Okay, when we're returning, we're going here. What? To the while loop? Wait, no. Because we're executing a jump instruction. What is going on? We are not doing the right thing. Okay, we don't need this at all. Let's make that a little clearer. Oh my God, guys, so much is wrong. We're skipping over instruction 3 for some reason. What is even happening? I really messed it up. Well, what did I mess it up if the debug break's not there? No, that's heartening. Or at least not for this simple program. So, so this PC is just being used for this stuff. So I guess this print single instruction already has a new line in it as well. Yeah. So I mean, I could just break somewhere. Like we could say, when you execute a return, what are you even doing? Why you end up elsewhere? What even line am I on? So we could say here, like we can just run it, let it loop, and break on 2783 there, right? See what happens. It's looping. Oh. Okay. Okay, well, we're stalled. Is it an actual stall? No. We are interactive debugging. Jump to block. Oh, we don't. Okay, I guess we're on a jump instruction. No, integer add to constant. What? We're supposed to set this to -1. So we're incrementing the index. Oh, I reverted the condition here when I should not have. Okay. Okay, people. All right. So now we're running, but then we're like hitting the end of a bucket. Index 63. There's 64 instructions to a bucket right now. And so hitting instruction 63 is bad news bears. Because we're incrementing. We're incrementing down here. See, I want to do this. I would like to have this in a hygienic macro, please, but I don't. So when we increment this index, we don't actually advance to the next bucket down here. Okay. What a butt pain. But I want this to be at the top of the loop, because the problem is if I run it here, which is kind of where I want to run it for these purposes, it'll interfere with these instructions. That's no good. I'm just going to paste it for now. I just don't know a good way to refactor it. See, we can't even go to loop is the here, go to reget. Go-to is considered, this is the most go-toing that I've done in a long ass time. I'm actually kind of starting to like go-to. It's scary. All right. We're returning because we are not handling. Okay. Reget just needs to be here. Because when the stack is over, the stack is over. No. Assertion failed TI. Oh. Right. It's expecting us to have stalled the outer thing. Okay. Ta-da! Okay, we now have a debugger, sort of. Not really. Not super much, but you can tell your program when to start dumping the instruction stream, which is pretty better than what we had if you want to debug at the bytecode level here. Let's make sure we didn't break nothing out of the ordinary, and then check it in. Oh geez, let's get rid of the run here. It was fun while it lasted. We'll do LLVM tests and x64 game. There we go. That's great. There we go. All right. Great. So we are about to have interactive debugger step 1. God. I deserve some chocolate graham crackers. Okay. Dang it. Now, let's add a new file, and I'm going to call it BC Debugger, because that's kind of like TC Tugger, but also we already have 2 files that start with bytecode underscore, and that's annoying for file completion in editors. Normally, I don't like weird names with abbreviations, but sometimes I make exceptions. All right, and then we'll make a BC debugger.h. No, not that. Debugger.h. That just came out wrong. All right. Let's go to our CMake lists for when we are on the terrible operating system. And bytecode builder, source BC debugger.cpp. Then we'll go into our frickin' this thing and add existing item. BC Debugger. Someone remind me to make a TC Tugger emote. Later. Okay. So we've got BC Debugger. It's a TC Tugger. And okay. Just making sure I don't have an emergency. Now, BC Debugger doesn't do anything, so let's just say, let's move some of this stuff into there. What can we factor? Let's make sure we can still compile. Great, great. Is an actual stall. I don't like how much code there is here already. I'm kind of, Okay, so this is just going to be bucket management. That's this loop's problem, and figuring this out is this loop's problem. This part is, yeah. interactive debug prompt, record bucket index. And then when we return from that, we just go to loop. All right. Okay. BC debugger. Call record instruction bucket and S32 index. Great. And that's going to be in the header because you have to do everything twice in C++. Only twice if you're lucky. And then we hope that these are defined, which, oh God, they're totally not. Oh yeah. Right. So now I get to figure out what I have to include, which is always a fun exercise that takes like hours. I don't think we need... All right. Interactive debug prompt. BC debugger is like TC Tugger. All right, so same thing. Now our interactive prompt is going to be the following. We don't have a fgetS, I don't think yet, equivalent. So I mean, maybe I can just call fgetS, but we're just going to go, we're just going to pretend like we have a prompt. We're going to go OS sleep 1000. That's how we know we're waiting for input. And then printf there. Printf is such a waste for things like this, but whatever, we're being lazy. Okay. Okay, that did not... What? Did we rebuild? Like what? Why didn't that sleep between every instruction? What the hell? Look, it's undefined, guys. Okay, we're running the wrong build. That's great. Oh, I was building release compiler again. That's why. Expert mode. There we go. It's going slow because it's waiting for me to type. But now it is no longer a thing. Okay. Guys, here's the thing. See how it's got like the file name and then a colon and then spaces in the number? That's really chapping my hide. Also the instruction index. We'll figure out a way to print this. That's better. Oh, we have 3 things that start with bytecode underscore. All right, so like a colon, maybe I put a pipe. I don't know. Because the colon is going to, like file name colon line number is something that we do all over the place in the compiler. So we want to do that. Is there a way in printf to left justify a number? Minus sign, is that global? Really? So I could literally just do this. Whoops, that. Okay. The pipe is a little weird, but the file and line is much better. You can actually sort of see what you're looking at. That's great. Now what? Let us what do people use? Like you used to use getS, but that uses a static buffer. What do you I just want to do something lame. getS takes a buffer with literally no length. Okay, they have some C++ size template version. I don't want to get wide string. Except you sort of have to. So you sort of have to do get wide string on Windows because if somebody types a non-ASCII character, you're not going to probably get it correctly unless you do get WS on Windows. But we don't care about that for right now. Okay. Okay. We're just going to do super crappy. Okay. For now, we're just going to do this, have this be a short-lived struct, but it'll probably get a longer lifetime later. It's just for now, we're going to do this. Okay. So the reason for that is because I want to do stuff like this. Handle command debugger and debugger. No, and debugger line. if debugger dot run code or debugger dot exit break. Okay. If debugger dot exit, then let's do. Okay. Anyway. We don't quite know what we're doing. We're not going to care that much because the more that we do, the better an idea we will have about what we're doing. So if you say that we should exit, we're going to say thread arrow interactive or stalled or interactive debugging is false and thread stalled is false. Sure glad somebody has a loud motorcycle. Really great for that guy. Okay, so let's make sure that compiles. Read next line we didn't do. Let's just say read next line BC debugger. All right. Actually, we already know it's greater than 0 if we get here. So we're just going to say debugger exit is true if you type anything non-zero. Oh yeah, we need that. Bool exit is false. And run code. Okay, let's just do this. If it's N, if it's C, we're just matching the entire line right now. This is stupid. We're going to want to like get the command and stuff. Anyway, this is exit. Printf, command not understood. Try whatever for help, except there is no help yet. And we'll return, but not set either of the things. Read next line. Oh, wait, that's handle command. This is handle command. Handle command. Read next line. We need our stupid. So what do we do here? Template size T size get us buffer reference for size or get WS. We're not going to do WS. So this should automatically invoke if we give it a buffer. All right. So all right, so we're going to say get us buff auto And actually, we're going to do this initial space chopping here. Just do that. Okay. We do the get s. Actually, no, we'll do it. Get s commit identifier not found. Standard IO. Standard IO. Get s identifier not found. This thing lies. Wait, what about the template version? All right, let's do fgetS. In number of characters. Okay, let's just do that. I don't know. We don't have standard in, though, on Windows. Maybe we do. I don't frickin' know. GetS. Do I have standard in? Standard in. See, this is going to be the stupid thing that takes all the time. Oh, it actually didn't. All right. Hello. Okay. Command not understood. Next. Command. Oh. We have to get rid of the new line. All right. So. Let's just go ahead and do some stuff here. Okay. So we're going to leak this on the, like it'll get reused on the debugger for every set of lines, but eventually it'll go away. Okay, we're going to go defer free line. Okay. Okay. I guess, wait. Do we get, no, we don't get a new line on fgetS, right? Let's just do this for now. So we're just going to say it's one word. So we're going to say words all right. Whoa, look at this wonderful stack. We try to take strlen of probably a null. Wait. Why does it have free and then strlen? That doesn't make any sense. Oh, we shouldn't free this because it came from our command buffer, so I'm an idiot. Congratulations. Okay, one word. First one is length 5. So it does have a new line. But when I do this, oh, because new line counts as is space, right? Okay. Okay. Oh, we do want to defer free all the words because we're going to be lazy. We're just going to heap allocate the words. We don't care. This is C. In our own language, we would be able to make substrings without reallocating, but C kind of forces our hand, right? A little bit. All right. While not is space. I forget is about 0, but we'll do that. All right, and then S equals T, so I don't think this should happen. All right. I type world so much from doing game stuff. Okay, defer for debugger words free it. All right. Blah. That seems fine. I'm sure that totally works. Oh, yeah. One words. First one is length 20. What are you smoking? T is S, while it's T and it's not space T++. Okay. Len equals T minus S. What is even happening, guys? I'm such a noob programmer that I'm gonna Tim Apple is gonna hire me because I'm the kind of programmer who steps through parse words. All right. Okay, hold on. That was a bad choice. Because we want a short word. A, B, B, C, C, D. All right. While star S. Boom, 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 boom. Wait, what? What about S? Line. Wait, we passed the wrong thing in. What the hell is line? Oh, okay, guys. This is so noob. What the hell kind of idiot am I? Okay. 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 You saw it here on the crank session. Me being a dumb button. Now this is C++ being a dumb button. I'm sure people in chat were like, no, don't do that. You're wrong. Okay, we still have this running for some reason. Because it's helping. Why can't I? Oh. All right. A, B, B, C, C, D, E, F, G. 3 words. First one is length 2. Thank you. Command not understood. Okay. If so we're going to check that these commands don't have extra junk on the end, right? So bool check words, BC debugger, num words, right? So this is just going to check that they're exactly equal. Okay. Is less than num words, else, and then return false. Printf, not enough words given for this command. Wanted %d given %d. Num words debugger words dot count and too many. All right. So if I say next blah, oh, it says command not understood. Why? Uh-oh. Oh, hold on. Yeah, we're doing the whole line. Okay, so auto command is word 0. Let's get rid of this. All right. Word debugger words. Debugger words. All right. Next blah. Too many. Wanted 1 given 2. Next. Ha, next, next. Calling a function. Next, 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 next. Continue. We now have an interactive debugger of some kind, everybody. Okay. Why is there an extra new line? Is that our new line? What the hell is going on? Yeah. Next, next, continue. Okay. There's all sorts of things we can do. We can print the source code line, which we actually have infrastructure to do from the debugger. We're not going to do that till after my 5-minute break, which is coming soon. Let's do help. Right? So you can say enter next, C All right, did I typo anything there? Okay, otherwise, if it's help, okay. Command help. Okay. 1, 2, 3, 4, 5, 6. Actually, let's just do this. However many that is, we're going to put here. See, this is a very precise, scientific, elite stream. All right, command help. Print this help text. N or next. Execute the next instruction. C cont continue. Continue the debugger. Continue running. What do I say? Continue running without the debugger stopping each instruction. Let's make another one. Exit. E or exit. Exit the compiler, closing all workspaces. Okay. Or should it be quit? Q or quit? Quit the compiler. All right. So if it's Q or quit, I forget what I call. We'll just straight up do it from here. We have like exit all interps. No. Interps should exit is true. Error all workspaces. Okay. Great. All right, next. Help. Command help. Execute the next instruction. Continue running, but without the debugger. Stopping for each instruction. Quit the compiler. Closing all workspaces. We can go quit. Help. Continue. Let's make sure we didn't break nothing. Awesome. We're going to commit further work on interactive debugger. Okay. And it's about time for my 5-minute break where I can adjust the temperature, warm up some water, and so forth. When I come back, I am going to, I think, so we could print out lines of source code, but I actually want to do something maybe more functional than that as well. So there's sort of two levels of debugging. There's like the bytecode level and the source code level. And we're sort of doing the bytecode level right now. And for that, I want to actually show what value numbers change, right? So each of these instructions does value numbers. And when a command reads or affects value numbers, I want to print before it runs, I want to print the values before it happens. And then after it runs, I want to print the new values. All right. Stop. How do I? All right. So I'll be back in approximately 5 minutes and we'll continue. Oh, do I rest for 2 more minutes? No, I'm ready to go. All right. Now, I want to print what registers change, or what value numbers, right? Our pretend registers And rather than make a big thing that hard codes that, I want to just know for each instruction which value numbers it reads and which ones it writes, which for most instructions is either writing nothing or writing to what's called the R value or R number. And at one point, I arranged all these instructions in anticipation of doing something like this, but I've since realized that I probably want to be able to order them freely for different reasons. And also, some of these instructions read R and some write R, and those are very different. And so what I want to do is make an array of things. We're going to say U32 see, I have to put this in Bytecode Builder, I guess. Register flags equals, right? And then we're going to go is equal to bytecode count, something like that. Yeah, okay. So that should all of a sudden not compile. Okay, we get this stupid unreadable error, cannot allocate an array of constant size 0. But what that means is that this static assert failed. So that's great. So we need to put all these numbers in here. And what are these numbers? Well, they're going to say what we read and what we write and so forth. And here's what I'm going to do. I'm going to say, I'm going to define some constants. Equals 1. Let's put read A as 1. It sort of goes A, B, R, 1, 2, 4, and then O is the rarely used extra one. And then almost all, let's see. I think comp exchange 16b is the only thing. So comp exchange 16b writes R. Oh no, it only writes R. Yeah, because the other things are memory locations. So it uses A, B, R, and O as inputs. So maybe we only need this. We will see. Okay. Now, we're going to make some common things. I have a feeling we're going to want to use these in multiple places. But we'll do it for now. This is, where was it? Oh yeah, right here. A, B is read A or read B. I'm just making some conveniences here. A, B, R. ABRO. And actually we want like actually AR, because I organize things this way. I don't think actually AB is a thing. We'll see. All right, so now, oh, and well, let's just have a none. So uninitialized, nop, return, jump, debug break, pause, mfence. Lee writes R. Oh, and I wanted to go. Capital means we write it. Load plus offset. Right. Puts that in result. Store plus offset. Okay. Assigned a big constant is big R. This is going to be the most common for a while. String literal function pointer. Call procedure. What does that put in R? Index type table stallable print register. I don't think call procedure frickin' puts anything. Yeah, that's misclassified, but we're not really trying to sort them anyway. So we're going to go 0 and then print register also doesn't frickin' do anything. And we're not going to need debug print register anymore soon. Okay. Null pointer check. This is false that it's R. Oh, but it checks A. Okay. Clear memory sized is R, 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 R. Wait, this has got to be writing R. Prefetch an atomic increment. Prefetch doesn't do anything. Atomic increment probably writes R. Nope. It reads R. Great. Some of these are going to be wrong because I'm just going to screw them up. Okay, jump if to AR. Do I have AR? I must have done that. Yeah. Okay. Jump if to compare one. Poke return value. Move A to R. Move A or 0 to R. Cast number to number. Let's do this. This is not going to be that readable of a notation, honestly, but I can search and replace it later, so it's fine. When I figure out what I would like better. So jump if to compare one, poke return value. move A to R, move A or 0 to R, cast number to number. Load plus offset, right? Oh, that's from A. Load from A into R. Store plus offset is got to be that. Integer add to constant. Multiply by constant, divide by constant. Okay. Logical not, bitwise not, negate, respecialize. I think these are all underscore AR. We'll double check all these later. We just want to belt them out right now. RD-rand, RD-seed, regs, keyword, byte swap, pop count, bit scan. Comp exchange 16B prep doesn't frickin' do anything. Yeah, see these notes are all kind of wrong. Okay. Atomic. The problem is when I reorder this, I'm going to have to reorder this. What about pain? Atomic and atomic or atomic XOR. Atomic and R is going to be an address. Array bounds check. Mem copy. I'm trying to keep the spacing the same. Integer add extend B. Subtract extend B. Compare to. Plus minus times div mod. And or XOR shift left, shift right, rotate left, rotate right. Mem set, mem comp, strings are equal. Compare and swap, atomic add, exchange CPU ID. And then comp exchange 16B. Did we decide that rights are or no? Yes. It reads R and writes R, which actually some of these commands might do. All right. ABRO or R. Respecialize part 1. Is RO? Okay, we never got around to that. ROR, Karl Čapek's famous novel. Okay. Was that Karl Čapek? I think so. Okay. Next. What the hell? Stack area not implemented. Three dummies. Dummy, dummy, dummy. Dummy, dummy, dummy. Get your adverbs. ABR. Really? I didn't do ABR? Oh. That's why. All right. We got them all. We got them all. Okay. Now, the easy thing to do is before we execute an instruction, we show what the values are going to be. And we can actually print them typed. Like, let's not do that yet. Okay, we already print out like big constants and offset. Yeah, okay. So values, for now, we will just print them as hex, but we can print them at the appropriate size, 1, 2, 4, 8 bytes. Yeah, okay. So, BC Tugger. Okay. So before the command, we're going to say print instruction values input values. Okay. So we're going to do the following. Oh yeah, that's not even in this file. We're going to put this one in this file, I guess. All right. Okay, who am I kidding? We want to pass BC Tugger to this. Call record BC concatenator. Okay. Okay, if okay, we want to say register flags. The sucky thing is that's going to cost us, like, how many lines is register flags? From 52 to 160. It's going to cost us 110 lines on the line count, guys. Terrible. Okay, bytecode instruction. No, we have our forward declaration here, right? Do we? What's it called? Register flags. Let's call it something a little bit better. Instruction register flags, and we can put that here where we have this. We can extern that. I think this will work in C++. I forgot to change the assert. BC debugger. All right. So, yeah, auto flags equals register flags BC instruction sub. Okay, if it's, yeah, okay. We can canonicalize, like, I'm not sure what order, with some of the funny ones, like if there's A, B, and R, and you read A and B and you write R, it's pretty well determined in what order the instruction printer prints those out. But for other things, it's like, I might not print the values in the same order right now, sue me. Okay, A, B, R, O. A, B, this one's called result, and this one's called options. And none of these should be called register. We're going to rename all this stuff eventually. It's fine. Okay. These are actually int right now. Value number. All right. We're going to put a space at the end in case we add any more guys, and we're just going to have an extra space, whatever, who cares? Aha. Here we go. Get value type from the bytecode and the value number. All right. Okay. Uh, 1, 2, 4, 8 default. I don't know what to put there, really. Oh. Is it signed? The bane of our existence. All right. If signed, we do this. R dot S8 else or .u8. And here we're sort of implicitly using C. So C has rules about if you pass an integer to varargs, what size it is, and it's doing sign extension here, whether this is signed or unsigned. So we're kind of like leaning on the C compiler for this. Okay, 8, 16, 32, and then I guess we probably have to do LL. And you know what? Let's make it X. Okay. So we're gonna put this here because again, we only need to test the unsigned because otherwise, you know, the signed would be non-zero as well if the unsigned is non-zero. Anyway, I don't want to print out the OX if it's 0. In fact, honestly, what do we do if okay, this is annoying. Like, right, if it's signed, what we really want to do is start getting more specific about what it is. Like, look, if it's a pointer, let's just print everything in decimal, actually. For now, reverse this, because that way we'll get the minus signs, and it's not what we're going to want all the time. But pointers, for example, okay. We can do pointers right away. All right, we could say I'm not going to use %p. Oh, I get. Let's just do this. Otherwise, do that. So many errors, guys. Look at all the wonderful errors that we are making. It's astonishing. Okay, bytecode, unknown. Easy. Signed, cannot be used with type bool. What? Oh. Dang it, signed is a keyword, guys. Register A. Index. Oh, it's called index A. I said it shouldn't be called registers, and it's not. All right. Okay, let's see what a disaster this is. Oh, let's go back to debug compiler in case things go wrong. Okay. Oh, we're not putting a new line. So this says v6 equals 3. For procedure calls, we should print the numbers, actually. Okay. So we need a new line. Okay, next, V6 is 3. Okay, we're not printing V7. So we're not, what we should do is when we execute the instruction, we also print the outputs of that instruction, right? We're not doing that yet, but we shall. Jump 2 if V1 less than or equal to V4. And so V1 is 9 and V4 is 1. So we're not going to jump to basic block 2. We are going to continue, right? Yep, instruction 4. V5 gets V3 times V1. So that's going to be 9. Copy V3 equals V5. So we could see V5 is 9. Add int V6 is V1 plus minus 1. V1 is 9. So V6 is going to be 8. And now we're copying it, and we can see V6 is 8. Wow, this is already better than GDB in some ways. Imagine frickin' that. Okay. Next step is to let's print out after things are changed. And to do that, well, let's make the function and then we'll call the function. It's going to be very similar. Print instruction output values. And we're just going to have to call it with a BC tugger, I guess. I mean, we really should persist this guy. So we're going to put him on the interp, the bytecode runner. Okay. Print instruction output values. Okay, so instead of read, we go write. And we're just going to put this doohickey. Yeah. That way it'll be clear. And, uh-oh. Okay. Oh, very good, very good. Very good. Print value number. Okay. Oh, no spaces. No space. Okay, great. I'm going to regret all this when I rename this to index R. It's going to be fun. All right. Yeah, let's undo that because then it's going to, I feel like that change is coming soon. So, where are we? We're printing instruction input values, but let's add another, so that's going to be the interior version. And here, let's just say, all right. So we're going to change a bunch of things now. We're going to put this concatenator on here. We're going to go we are only using dynamic allocation to create this so that we can forward declare BC debugger and try to keep C++'s suckiness to a minimum. Trying to keep my typing suckiness to a minimum. All right. Init that concatenator and have debugger. Oh, we don't need to do that. We'll have output values is false. Okay, but if you say print output values, wait, input output values. I was doing the wrong thing. Okay, if we have this, then debugger have output values is true. True. Okay, print instruction output values. Okay, output values. That's going to go here. And I mean, actually, you know, it's going to be like this. We're just going to make that, okay, that's going to be callable externally. We're going to go here. We're going to do this. We're going to do this. Somebody's going to want to call this. And we're going to take off these concatenator arguments. Okay, we need this as well. And print single instruction. Okay, before we print the instruction, if debugger arrow here whether we have a string. If debugger have output values, then I don't remember if get result resets, but okay. have output values as false. Let's just put that straight up, straight away. Okay, this thing here, this is not right. We're not going to keep these actually. And this is going to be a BC debugger. All right. And all right. And this is going to take an interp. That's just a standard thing that we do, is put the interp on everyone so you don't have to go very far to get it. Return debugger. I bet people were screaming in chat, return. You didn't. Yeah, return. And it's like, okay, yeah, I get it. I get it. I didn't return. Interactive debug prompt. No problem. Bytecode runner. Interactive debug prompt. Interp arrow BC debugger. All right, well, what the hell is that? Well, we're going to forward declare it so that you don't know. You have no idea. Okay, and then let's make it null because we don't always have one. We're not going to have one unless you invoke it. And the way you invoke it is, as we said, with the debug break, let's call it make BC debugger. BC debugger, right? And then BC debugger is like TC Tugger. Okay, not really that many errors for how long we were typing and going back and forth. Okay, there's a missing character there. Oh, look, I literally just did that one. Okay, write a undeclared identifier. BC debugger doesn't know about these. Aren't those in bytecode? Oh, write a. Oh, we don't have these. Whoops. One oh, 20, 40, 80, and we go. Print value number, const char. What? Dude, I hate C++. Just go jump off a cliff. Const char. Const char. Const char. Print single instruction. Run code. Okay, cool. Let's see if we can still even start it up. Next, next, next. Okay, great. So we have made the provisions to when we do a command not understood. Oh, we're not clearing the other flags. Okay, that's a little bug. When we do the, okay. I Exit is false. Okay. Maybe I should reset those elsewhere. Okay, but well, actually, you know what? I actually don't. This trailing semicolon. Let's actually make it a comma. You know, sometimes these things bother me. Okay, instead of a... We want to put a comma if it's not the first one. So we're going to say starting length. S64. C dot length is greater than starting length. Then we appended something. So we add a comma. Okay, and then where did I put that? Value number concatenator. Before. The before times. No. So much hassle. Okay. Great. Let's see if that works. Duh. We know that's not a dot. People in chat were yelling, that's not a dot. There we go. Okay, it's a little more minimal. Now what? Well, we want to print all this stuff that we did. So we have this provision for print instruction output values, and we don't exercise it. I think we can slot that right in. So way up here before we do the plus plus, we know we're about to do the plus plus, right? We're interactively debugging. It's not an actual stall. It's not one of these instructions. Oh. Actually, we still have the value of BC. We could keep the value of BC around. Let's do that. Okay, you know, I set this up to get called from the outside, but we're not even going to do that, I don't think. Hold on. None of these guys actually write registers in the way that we want to print right now. So, I mean, returning from a function does, but we could deal with that later. That's sort of a different thing. We can just do the thing here. And we can move it later. BC debugger is like TC tugger. Print instruction input values interp BC debugger record BC. All right. Output values. Output. All right. A. Next. Okay, that didn't do anything. We are clearly not doing anything. Okay. Wait, why are we here? Oh, because they're the first one. Okay. So we're going to say next. So now this should be the constant. Oh, no, parse words. No, we don't care about that. So BC should be the assigned a constant. Yes, it is. Okay. The flags should be right R. It is. Okay. Print value number, BC index result before separator. Boom. Great. Great. Wonderful. Add a new line. We have output value. Did I just not print it? Was I like a jackass? Okay, so we go here. I get the result, and I simply just don't call print on it. Ladies and gentlemen, I now work at Applebee's. All right. All right. Why isn't it working? Computers are so hard to understand. All right. So this seems redundant, but this actually says, so this V6 equals 3 could have happened a long time ago. It just so happened it was written by this instruction. So when we run that instruction, it puts 3 into V6, right? All right. So V7 got 9. And now we're calling factorial of V7 to V9, right? Constant V3 equals 1. V4 equals 1. I should probably make it so that enter just steps 1, right? That honestly should be, because you always want to step in an assembly situation. Oh, should I make it step instead of next? Dude, I don't know. I don't know what commands this elite programmers use. Mmm. They should call them wolf chips because I wolf them down. Non-stop glutton chips. All right. So, interactive debug prompt. Oh, yeah. Read next line. We're just not going to do this, right? Okay. We're just going to go if debugger words dot count is equal to 0. I just typed that again. All right. Great. Okay. Let's make sure we didn't break anything, and we'll check that in. And now we're going to do something that's a complete, well, first we'll check in. Let's make sure everything works. But then we'll do something that's a complete travesty given the current code base, but sometimes that's what you do. Sometimes that is what you do. Okay. I would like to show the line of source code right now for each instruction. But later, we could only do it when the line of source code changes. All right. All right. And we're going to, this is going to be so stupid, it's amazing. All right. More work on bytecode debugger. I kind of should have done this a long time ago, honestly. I just didn't, like, sometimes things seem like systems that you're never going to have, or that I don't know, like that you already have too much to deal with and you don't really want to do this way, and someday you're going to have it run machine language anyway, so whatever. But given how easy this was to do, like just having what we programmed today on this stream would have helped me sometimes a lot. And it was so easy. All right. Live and learn. That said, I'll accept it. I mean, I have a bias away from investing a lot of time in tools, quote unquote, up front, because that is how a lot of people in the game industry failed early on. They were just like, oh, we're going to write our awesome engine, and then they never do their game or whatever, right? So, like, there's a little bit of that going on. Okay. So we have this thing, when we're printing an error message, we show error context. And Okay. This is going to be so stupid. The question is, do I just call this for now? Or do I call let's do this. Okay. Interactive debug prompt. We're gonna, okay, before we do this thing, before we print the instruction, we're gonna go, if we have a debug expression, wait, that's the, yeah, okay, sorry. I got confused from the other thing that we did, which got called with the previous instruction. If it's got a debug expression, which I think everything has a load, but we're going to be paranoid. Load. Let's just do that. Let's just be super stupid. Like, that's just what we're doing right now. Interp. So now, the thing that you should know is every time we print a line of source code, the reason why this is so stupid and horrible, the error reporting is currently just made for usually reporting an error and then quitting, right? So every time we report an error, I believe, I might have done something slightly better than this, but every time we report an error, we load the entire file. We search from the beginning of the file, counting lines till we get to that line, print those lines, and then exit. So we're going to do that every line in the debugger. Yes, this is Applebee's quality code, but like, oh, I'm making release compiler, by the way. You know what? I wasn't really testing things. I hope people in chat notice that. All right, here we go. Oh my God, look. I guess I was testing things. Okay, so we have a few problems, like this source code printer. It's putting new lines and stuff. I don't know how I like that, but you can see like the highlights are actually kind of useful a lot of the time. Sometimes they're not, but like, hey, the 1 is highlight, constant v4 equals 1. It makes sense. Jump, well, you know, whatever. Bin up, minus equals. If we were in a more interesting function, oh, we could be, we could do like up, right? That's a good GDB thing, like continue until we return from the function. So here, string constant. Oh no, that's the length of the string. And here's the address of the string, and we're putting the string literal. Oh, the string literal count, string literal data. V14 equals 1. That's for the any. Oh, the varargs array is length 1. Yeah, this is going to be a bunch of instructions to do this printf. Oh. I guess we finished the program. And we don't correctly check for finishing the program when we're in interactive mode. Let's fix that. Wait, No, because... Does it happen? Let's move our debug break down here. Really? Print value number. Oh. We're printing. So what's happened is during a procedure call, you switch call records. And I think we're printing the value number from the old call record. No, but we're printing input values. Question mark? Did we somehow get the wrong call record after a call? If there's a call, we're supposed to re-get record here. The call should have pushed a new record. We're supposed to re-get the record. We do the index. We do the interactive debug prompt. Huh. Are those not correct for fresh calls for some reason? Let's see. So we're going to start this up. We're going to run for a bit until we get to the call. Here. We maybe should put the comments closer in this mode. Anyway, actually for all modes now. So we do calling. This record, this index. So now the record stack should not have this record on top. Unless it's an intrinsic, but this isn't. We're calling print. That's a function of its own right. So thread call record stack has three things in it. And record should be the middle one. Yeah, and it is. So this is as expected. We break. We get our new record. That's the top, or the peak. We get the bucket and index. Bucket is whatever. Index should be 0. Yes. Okay. Next PC should be 0. BC is init stack trace node. Okay. index result is 11. What? Wait, what? 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 I mean, maybe if some code is generating that, that's kind of whack. Record value numbers somewhere. Eight. Num registers 8. So that's more than 8. Great. Why? Okay. Record bytecode has really 11 instructions. So did we overwrite this somehow? What happened? This is very weird. Let me just make sure. Oh, wait, this bucket and index. Are we really sure about this? Record, bytecode, first bucket, instructions, sub-0. Yeah, it really ain't good. Oh, wait, no, init stack trace node, it's, okay, the problem is R is not actually a register there. I have it mismarked. Or a value number. I'm trying to change terminology. See, this is the serial number of the lambda in that slot, which means oh great. So I could put the names next to these in comments. I probably should. Let's do it, because when I reorder these later, it's going to be painful. But let's fix the bug first. It's init stack trace node. So that's not that far down, thankfully. Question mark. Let's help ourselves out here. Come on, Emacs. Bam. Oh, look at that. Look at that. Okay. Init stack trace node is a big 0. Init stack trace node. Okay. Let's build that. Oh, yeah. Oh, yeah. Oh, yeah. Go, 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 go. Go, go. Did we went to like 39 before? Oh, no, 29. There we go. And then we called the procedure. And now we're doing print to builder. So like, we're really going to want a better system for printing line numbers, etc. But like, this is pretty good for 1 3-hour stream. I'm cool with it. Now we're doing a subscript. Now we're doing some things. Now we're doing some other things. Okay. Let's do, what do you call it? Like, what is GDB's command for GDB run until return? Use finish, or finish is kind of lame. Does LDB? I think just saying return. We'll put finish just for BC Debugger is like TC Tugger. We'll put finish, return. Where's my help at? Oh yeah. Finish, run until we exit the current procedure. Return from the current procedure. So if we have that, that's our return finish. Then debugger returning is true. And then here we're going to say okay. So now when we go down here, if this is going to be slower because we're going to jump to loop. BC Debugger. Oh, dang it. Wait. Oh, we don't even... bcdebugger.h does not tell you how to TC Tugger. All right. Is not a member of Bytecode. What? Why did I say that? Interp BC Debugger return and go to loop. Okay. So, oh, of course, ungrateful file. All right, nope. We're still running here, that's why. All right. Oh, let's change our breakpoint. Because remember the annoying thing was I go down into factorial and then we're doing like 9 factorial, right? And it takes a while. So let's do that. Let's go here and run. So 1 plus 2, that's 3. X times 3, that's 9. I should put a new line there just to make it more visible. I don't know. There's a lot of new lines here right now. We maybe shouldn't put one after the source code. I don't know. Like, I feel like this should use syntax highlighting and stuff too, but we'll figure it out. Okay. Z is factorial. Y, we're going to step. We're iterating. Okay, what if we return? Didn't work. Oh, because we didn't say exit. Oh, but now we did. Okay. So I had to step once, but we set the return flag and then we did all this stuff and then, okay. So, I mean, you probably don't want to see all this stuff. We could turn it off for now. But we might make an option later to turn it on. Okay. Output values. If VC debugger returning, we're going to want that to make that a function later, because there's a number of times you could just be, I don't know, running. There could be a run argument with a number of instructions that ticks down. Like we're going to want something. Okay. Anyway, and then when you say returning, we want to say exit. Let's not call this exit. Let's call it resume running, right? Because if you just print a value or something in the debugger, you don't want to resume running. Resume running. Okay. So we go, we're down inside factorial. You know, there should also be like a step over versus step down. We don't have that. So that's another thing that we might add. Okay. So we're going to go return dough. Okay. Oh, because we skipped over Applebee's. Oh, Tim Apple will never hire me back. Tim Appleby is my only employer. Returning. Wait, no. Oh yeah, we got to do this. So if we're, wait. Hold on. Did I break the... No, that's only about printing this. Okay. I must have just... Did I turn off interactive debugging accidentally? Okay, I got it wrong. Resume running is disable debugger. And see, I got confused by the wrong name, such that I even changed the wrong name the wrong way. So run code should be resume running. That makes more sense to me. But resume running is going to be disable interactivity. All right. Okay. Great. Even longer. And then run code is resume running. I'm fighting the eternal war to line up the equal signs and not wanting to make my eLisp do it. All right. Okay, return. There we go. Let's actually also, when we print returning, we can actually print it if we're exiting that mode. So we go here to do factorial return. Bam, baby. Now we're back. So N really should take you to next statement. And what we're doing is stepping, right? But I don't want to do that yet. We have 2 minutes left in our jam. So we might continue this, but we're gonna test and commit so that we can have closure. Like, hey, we made a bytecode debugger on this stream and it works. If only we had a borrow checker, we would be here until next week making it work. But we'd swear up and down that the borrow checker helps us program better and faster. All right. This is great, guys and gals. And I don't know, at some point, the aliens are probably watching, right? Aliens. Lex Friedman knows about the aliens. All right. So this is all good. We can commit this. And let's actually, let's scan for no check-ins. Let's go to... So to do S steps and goes to next statement. Don't make statement reporting so horribly slow. Don't. Oh, I was going to say don't print a new line. If the location doesn't change. Don't print a new line if the debug expression doesn't change. That'll just reduce. And then you'll get less of like the same line of code, and it'll just change when. And we could even have like we could have a step that goes one, a next that goes to the next line. We could have like M for being like N that goes to the next debug expression. So we have a debugger period. Okay, commit, and there's the alarm that we have jammed. We have cranked. How nice. How's it going, everybody? I'm turning chat back on. How's it going, everybody? Any questions about what we just did specifically while I warmed myself up some more tea? That was fun. That was only the second one of these that we've done. I had a good time. I'm sure the beta users may appreciate this. I mean, it's not a fully featured debugger, but it's way more fully featured. Oh, you know what we could add tonight? Out of crank mode is when the compiler crashes, it'll do a trace back of compile time execution. And I don't think it's a good idea to automatically drop you into the debugger because it might be running in a script or something. But we could say, hey, if you want to debug this, run with the like debug command line option. And then it'll drop you into the debugger when your compile time execution crashes. That would be a fun thing to do. But first, questions. Any questions, guys? How many are there? 10 people? There's 318. That's great. What debugging existed before the Sapphire? Well, we had machine code debugging via general machine code debugging mechanisms, but we didn't have much for compile time execution. There was sort of a verbose flag that nobody knew about that you could pass, but I didn't even use it because it was very spammy. So this is great. There was basically, we went from nothing to this thing that we have now. Nobody has questions. I'm actually going to make sleepy time vanilla tea. So maybe I will just rapidly want to go to bed. Chat was quiet for most of it. Well, nobody's saying anything, so I guess maybe nobody watched it, the video. Or am I not even seeing all of chat? I wouldn't put it past Twitch not showing me anything, but there's literally no chat. Well, not literally no chat, but like, it's been quiet. Okay. Well, maybe that was worth doing. I mean, it was very worth it to me to do because we have a bytecode debugger now. It's just, was it worth doing on Twitch? I don't know. There are a few trolls at the beginning. What were they doing? There was one that was insisting that go-tos are bad, and everyone knows that. Go-tos are so bad. Go-tos are so bad. Oh my God. How many go-tos do I have in the compiler? Let's find out. I probably doubled my ratio of go-tos. Okay, the problem is we have variables called go-to. So I need to go go-to space. We've really got some go-tos. 4, 5, no, wait, those are prints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 6 of those are like today. 11, 12, 13, 14, 15, 16, 17. There's like 20 go-tos. Some of those might be in comments or something, right? But 20 go-tos in a 50,000 line program doesn't seem that bad to me. Will this help dramatically improve debugging? No more GDB? No, you wouldn't. So this is for compile time execution, not executable execution. Can you show some so people would understand why one would consider using GoTo? I mean, I just did during this stream. Like, what more do you want? I used some frickin' go-tos. Okay. We could actually also, you know what we could do? Okay. Let's make the thing crash on purpose. And I want to see I want to find the stack trace thing because I don't remember where in the code it is. And then we can hook that into the debugger as well. Oh. Wait, it didn't. Oh. Dereferencing a void pointer isn't actually a crash because void is size 0, so you don't read anything. There we go. Okay. Actually, that's the wrong stack trace. Oh, but when we panic, do panic. Here we go. Print call stack of thread, and we're just going to put that in this other place. All right. BC Tugger. Okay. And if you do where help, right? I'm going to put this in alphabetical order. Is that the right thing? Is that where in GDB print the current call stack, or just show the current? Okay. Let's just pass thread here. Don't I like coffee? I don't really like coffee. Yeah, when the Sokoban game loads animations, it's a super long stall, and it starts with no animations loaded. So at first, anything you do, it's a super long stall, but then it goes faster. And it's on my list to speed up animation loading anyway. So yeah. All right. So we're stepping down, and we go where? W. Wait, what? Did I not recompile? Oh, wrong one. Wrong one. There we go. Okay. So what? I kind of feel like I want to do Miller time now and just chill, honestly. Like this is enough for me for tonight. Well, no, let's try. Let's try the Okay, well, let's start feeling good about ourselves. There is now an interactive debugger for bytecode or for compile time execution. Use the debug break intrinsic at compile time to invoke it. Type help to get a list of commands once you are in the debugger. That's like enough to ship another beta, but you know, I want to put in this compile time option. So what I want to do is say if we are executing, so let me take our debug break back out. Actually, let's commit this. So we actually don't need to worry about this. If this leak happens once per interp, it's not worth talking about yet. Also, we don't need to clean this up because we factored it into the thing. Okay. So now what? What was I going to do? Oh, yeah. So when we were running, when we're running, this, where we print stack trace, actually. Oh my God, we have 4 places where we say that? Are you kidding me? One of them's probably Linux. Okay, I remember being very grumpy about what this code looked like and wanting to fire people. I remember there being way too many copies of this and like WTF is going on. So there's that one. Okay, what are this is do assert. And then one for each there. Okay, I don't understand why assert is like doing a different thing. It doesn't make sense to me. But okay. So instead of printing the command line, I mean, I guess we could do that, but instead of, okay, before we do this backtrace, like backtrace just calls backtrace with, like, what? Okay. No check-in, make this work for Linux 2. Okay. If show compile time execution stack don't show the dump of the program, else this happened outside compile time execution, so it is likely the compiler's fault. Stack trace of the compiler. All right, so now show compile time execution stack of I mean, do we know what thread it is when this happens? Why are all these indented? That's driving me nuts. What is in an exception pointers? Is that one of our thing? No. Exception record, context record. State of the processor, exception code, exception address, number parameters, exception information. How do I know what thread? I don't care about manage threads. Wait, do you set this handler per thread? Wait, what? I don't frickin' know. Is there going to be a nice way to display things like the contents of resizable arrays? This might become the best way to debug programs. I don't know. We'll see. Like, we just have to see where it makes sense to take it. I mean, honestly, it's not that hard to get that information out of Visual Studio or whatever, but you wonder if they'll just enable the Linux subsystem system-wide? Oh, God, no, they won't. Are you kidding? Are you kidding me? Don't like pthreads? No, I don't like pthreads. And also, like, Windows is an actual enterprise operating system that has customers. You don't, like, do that. Maybe the handler runs on the thread that failed. It's quite possible. Let's find out. Get current thread ID. Something about this file looks so spammy. Like, I don't want to be in this file. I don't understand why. It just looks very ugly to me. There's something about this file is wrong. And it makes my brain want to scream. I'm just going to keep just editing it in tiny ways. No. And we'll eventually get it somewhere. Okay. Anyway. Just little by little. This frickin', why is this indented? Why are we if defined? Who is doing this? All right. What does S underscore mean? Static? Fuck you. All right. Okay. I'm just gonna do what I could do. Why? Okay. We have a get current thread already. Oh, but we don't. Okay. So what was I doing? The back trace. Show compile time execution stack. We're going to return false. dword ID is get current thread ID. This is temporary. We're not. This is going to be an operating system independent thing. Right here, we're going to go printf. Okay. Thread ID 25912. Okay, but what are the thread IDs of all the interps? Oh, wait, we have thread local interp. Oh, that's better. That is better. That is better. Workspace 1. That seems pretty correct to me. Okay, so we will say running thread. Okay. If there's no running thread, we return false. Otherwise, we return true. And we go printf this crash happened during compile time execution, so it may be a bug in the program's own code. Not in the compiler. Here's a stack trace of the running of the compile time execution. And then we go PC tugger and we go print call stack of thread. That's great. Okay, so now we have to go to bytecode runner. This calls continue bytecode. Running thread equals thread. And defer. Well, now we'll go. Running thread is null. We might actually want some crash envelope around this, really, but we'll see. Print call stat. We don't have TC tugger from there. All right, so. This crash happened during compile time execution, so it may be a bug in the program's own code. In what program? In the user level program, not in the compiler. Okay. Now, I believe we were holding a mutex back here. How do I continue? What are the enums? How do I just... How do I just say... Oh, I guess we can just go to the interactive debugger. Yeah, all right. Don't show the compilers. Stack. Go to the interactive debugger if we want that. Debug bytecode crashes. Then, well... for an indefinite period of time, exclamation point. Okay. If the system debug bytecode crashes, we make our TC tugger, and then we go oh. This is kind of a problem. We don't... See, we don't actually know the place where it crashed because we're keeping those in local variables for speed purposes. Okay. We will, okay, we'll write them every frame. Ugh, gross. Okay. One thing at a time. The problem is we don't write these in an attempt to be fast. In this actual language, we could easily generate two versions of the bytecode running loop, one of which writes these and one of which doesn't. But in C++, that is more brutal. I mean, we could do it, but it's gross. It's gross. It's gross. Okay. People in the Linux community speculating that Windows will eventually become a shell running on top of Linux do not know their Microsoft history. They do not understand Microsoft. Everyone who was involved in Linux in the 90s when it started knows this play. Okay. Okay, else okay. So this will give us something. It's just not yet the right instruction. We need to go to bool debug compile or debug bytecode crashes. Right, and then we go to main. Dash debug system.debug bytecode crashes is true. True. Really? It's not called resume BC index. What's it called? Oh, resume PC index. Okay. Bam. Here's a stack trace, factorial main, whatever. If you want to interactively debug crashes, run the compiler with the dash debug. So then I go dash debug. And here we go. It's leaving us at the beginning of the function because we don't know what the hell's going on. This actually isn't going to be that good without further work because it's going to leave us exactly at the instruction that crashes, which like you can't see that much context around it and whatever, but Yeah, really didn't like that. Okay. Oh, we need to do this. Oh, no, that might be crashing or something. What do we do? Debug break. Oh, interactive debugging. Duh. All right. Next. Okay, it's frickin' crashing. That's fine. Probably. Okay. Well, who knows? We'll see what we're able to do from this debugger. Now we need, though, in bytecode runner, right before we run any execution, we need to say record resume bucket is bucket record resume PC index equals index. There we go. There we go. We're dereferencing V at line 10. You know, this whole thing about showing the line number and stuff, if we're going to print the line, maybe it should be up there. I don't know. But anyway, there we go. V8 gets V7. V7 is null. How good is that? It tells you exactly where your meta program crashed. I think the beta users who are doing sophisticated meta program things. Oh, we could say we want to say what workspace it is. Of workspace number 1. So it may be a crash. And then, so before I go to bed tonight, I got to test this on Linux. Here is a stack trace of the compile time execution. Boom. Boom. So good. So good. All right. So I have to make this work in Linux. And that's just going to be the same. Handle exception is going to be the same. so good. Wait, we're still running. That's the problem with having an interactive mode, is I keep not getting it. All right. Bam. All right. Let's test and check in and test on the Lappy Tappy. Oh, let's document the option. Invoke the debugger when there is a crash during compile time execution. Execution, report the stack trace of the user level code rather than the compiler's stack trace, and tell the user about the debug option if it is not set. This is going to be such a good beta. Okay. Now this is a real option. So in the help, oh my gosh. Okay. Good. Good. Should you call leave critical section in the if block? Oh, good point. Right. I was remembering to look at that and then I didn't. Oh, I also put this in the wrong place. Oh, no. I mean, we could do this up here in case there's some weird output. All right. You know what? Let's actually... Let's actually put this here. So that way we don't have to write it separately for Linux. Okay, so leave critical section, I mean, I don't know if it matters. Like, I don't know why we're doing this versus, I mean, you know what? We're just doing that. Okay. I mean, we're sort of going to standard out up there and then standard error down here. Are we? No, we're not. Actually, I said standard error. The problem is the debugger is standard out, so that's a little weird, but it's fine. It's interactive. You're okay. You're okay. All right. Great. Who even knows what is happening when you try to, let me, if I do this, can I do help? Yeah. So that's great. So we'll be able to print values from here and all sorts of things that are useful. Okay. Great. Going to test again. Yeah, I did it on the crank session stream, which we're still kind of at the tail end of, but the intense part already happened. Do I think GFX HAL is a good idea? Vulkan that JIT compiles to Metal or DX12? No, it's awful. Get that shit out of here. It's like they've forgotten what the point of Vulkan was. How long was the crank? 3 hours? Yes. It was 3 hours with a 5-minute break in the middle, but the 5 minutes was not subtracted from the 3 hours. So it was 3 hours and 5 minutes. Except the break was actually, I think, a little bit less than 5 minutes. Okay. Yeah. So we commit invoke report a stack trace and invoke the debugger if crashing during compile time execution. Okay, let me get my laptop. Wasn't one of the points of Vulkan to make it so you don't need to do vendor-specific stuff 4 times? No, that's what OpenGL was trying to do. Vulkan was supposed to be a vendor-agnostic, low-level graphics API. Low-level. It was supposed to be you telling the hardware exactly what to do. Okay? They've given up on that, which means that Vulkan no longer really has a purpose, except in a couple of places where it's actually the native API. Like now it's like cargo cult low level. It's like hard to use, very fiddly, annoying to program for, and not even the native API. So like, why are you doing all that? It's terrible, right? If you want something that's cross-platform and not and vendor agnostic, you should use something that's like a modern SDL, that's its own graphics API, that's higher level, that lets you drill down to a low level where necessary, and that's not a giant pain in the ass. Vulkan is the wrong thing. It is a mistake to use Vulkan as a layer over other things. Okay. So I actually want to go into Sokoban or something, or no. Something happened to my Windows where like my Emacs window is locked on top and it's super obnoxious. Like, how did that even happen? I'm gonna have to reboot this computer. I'm just gonna pull a little program over here. How about this one? Is this one better? Will there ever come a time when you can just deal with one API for everything? When you can program a GPU like you can program a CPU, then you need 0 APIs. And that will be freaking awesome. All right. So I'm just making a little program on Linux that crashes, and I'm going to try it out. It's annoying because I have to keep minimizing my Emacs. Oh, I've got to make it crash during compile time execution. That's the whole point. Run main. Yeah, baby. All right. Here's the stack trace of the user level program. Run the compiler with the debug command line option. I'm doing that. There we go. It is telling me exactly where it crashed. So this all works on Linux as well. It's Miller time. Sort of. I mean, it's not really exiting correctly. Are we missing? Actually, can I do commands? Ooh, Linux is not letting me do really anything in the command prompt. That's bad. Do we have a mutex here? Do I have to do something in Linux before I can like I feel like it's like standard out or standard in isn't working now or something. After the exception. Is there a way I can make standard in work? Let me make sure it works at all. Hold on. Debug break. No, it just totally doesn't work on Linux. Did I if-def that for Windows? What's going on? Does standard in like not work on WSL? It's odd that Doom Eternal went with Vulkan. Well, original Doom 2016 went with Vulkan. And that kind of made sense at the time because we didn't know what a cluster F it was going to turn into. I mean, if they shipped it in 2016, they were doing Vulkan in like 2014 or earlier. So, like, we're talking decisions made a long time ago. I mean, I don't understand why fgetS isn't working. Wait. fgetS is returning instantly. Oh, you can't fgetS on standard in Linux, right? You have to. What's the current right thing to do? Or no, I guess. I don't know. fgetS is returning null. So Vulkan is bad now? It's been bad for years. Okay, well, fgetS returns null, which means standard in is non-blocking. How do I do a blocking? Did somebody set standard in to non-blocking for some reason? Did somebody like ioctl or fcntl or something? What is even going on, guys? Is somebody fired? Oh, I already had one. What do you mean 0 files searched? What is going on? Is it space? Okay. I don't know. What changed to make Vulkan bad? I mean, it's been kind of bad. I just explained. Like, guys, I literally just explained. What? Why would... A null is an indication that it encountered an error or end of input. Why am I having a problem? Is this a WSL thing? Like, has WSL hosed my fgetS? Could probably check Erno. Yeah, I just hate Erno. It's just such a broken, stupid way of doing things. Undeclared identifier Erno. We don't have Erno for some reason. Do I have to include erno.h? Erno.h, okay. All right, I had to exit my Emacs because it was driving me crazy. Okay, still Erno is 11. Linux Erno list. System errors 11. Try again. What do you mean try again? Try again. All right, I'm going to see if that's just WSL being stupid. Try again. That wasn't good enough. You didn't fgetS good enough. Okay, I haven't used this laptop in like 6 months. I almost didn't remember the password. Update. Hey, at least my Subversion doesn't ask me for the password every time because they set up the frickin' key ring. Oh yeah, we're pulling down the new LLVM now. Oh yeah. Oh wait, it slowed down. It was going fast for a while with all the files. Try again, you didn't do good enough. Yeah, that's basically what happened. My idea about it being in non-blocking mode might be correct, but how would that happen? Like if my program doesn't do it, how is there a way besides ioctl or fctl to set standard into non-blocking? Is there some other thing that would do that? It starts out blocking on Linux by default, right? Like it just I don't know. I'm just chilling, waiting for LVM to come down. Waiting. My phone also wants me to update. Have I gotten any GME stonks? It's Saturday. Stonks don't Saturday. Wait, is it Sunday? It's Saturday. I don't know what day it is. It is time to download LLVM for hours and then figure out your compiler won't compile. You can stonks any day now, then why is it after hours? All right, well, we updated. Let's see if we could build make. No, oh, cmake dot. Nope. Could not find, oh, I need to install LLVM. Could not find a configuration packet for package LLVM that is compatible with LLVM 11.1.0. Oh, so on this one, do we just not know an LLVM newer than 9? What the hell is LLVM called? How do I fucking hate Linux. Just install the newest LLVM. I think it's called LLVM. Apparently not. Is it just LLVM dev? But then how do I say version? Yes. Nope. It's failed to fetch a bunch of packages. Just use Arch. Yeah, no, that's not happening. LVM 11 dev, that is literally the first thing I typed. Wasn't there. This is Pop! OS. It may not have these packages anyway, at which point, what is the point of using Linux? Apt update. That's a good point. It's apt update. Updating from such a repository can't be done securely and is therefore disabled by default. Okay. Is there a way to list packages with a substring? No, I don't want installed packages. I want packages I can install. Like the thing that everybody wants to do. I'm searching for this and it's all list. Search your installed packages. If it's installed, I don't care. All right. People are saying apt search LVM. Okay. I see a bunch of packages that I don't care about. And it's all LVM 9. Clang 7, LVM 9, LVM 7, LVM 8, Python LVM. Yeah, just rip. Rip. Is the session over? Yep. It was very successful, except for this last part where we ask why we can't fgetS on Linux or on Windows subsystem for Linux for Windows NT. Okay. Yeah, there's nothing past LLVM 9 on this. Can I just like download a Debian package or Debian or... I'm so tired of this. I can't. I'm just going to cancel the Linux version of the compiler. I don't know. LVM.org has some things. Okay, let's try this automatic installation script. Let's try this and see what happens. Oh yeah, that's doing something. And then it complains. Sure doesn't look like it installed LLVM. Yeah, can I just update on Pop! OS? Can I just like update the entire operating system, please? I mean, I know I can do like apt upgrade or something, but that seems dicey. Let's see if they have an official. Pop! OS has a GUI for upgrading version. How do I find that? Settings. No. Utilities. Update. It's telling me about a program called But, which is what I think of all of this. You'll stay on the same distro version? No, but we need to upgrade the distro version, probably. Software Center. Software. There's a Pop Shop. Let's open Pop Shop, where I can unleash my potential. Updates. It's picking sources, but it's not telling me extra sources. Okay, fine. This is just a GUI to apt. I still don't see how to, oh, system. I don't see how to update. It's not telling me how to actually update. A dist upgrade might take a long time. Yeah, but that's fine. It'll take longer than, or it'll take less time than trying to figure out how to get my app working. I really don't see any place to do a dist upgrade in the GUI. It's like really not. The update list, but there is no update list that I could find. There's a tab that says updates, but it just controls update sources. Oh, wait, if I go on install, oh, there we go. Operating system updates. But that's for components with updates. What if I want to revise the whole distro? Whatever, we're going to click it. Update. Authenticate. Downloading. I feel like this still isn't going to do the right thing. Won't it be easier to build LLVM from source? When I tried doing that on Windows, it took me 3 days of pain. It might be easier on Linux, maybe. Like 3 days of pain, not an underestimate, not an exaggeration. I don't like people who say imagine whatever. It's my pet peeve. I don't want to talk to those people ever in life, ever. It's like the number one most unappealing thing that anyone can say, regardless of whether I'm the target of the imagine or not. How long? No, that was a ban. That wasn't a mute. I have no room for imagine people on this channel. Except John Lennon. John Lennon is welcome on this channel. All right, so this is just, I'm just going to let this download forever. I'll wake up in the morning. It'll either be completely broken or it won't have updated anything that I care about. So we'll see. All right. So I think that's going to end the stream. I'm a bit bummed that I can't run fgetS on Linux. Well, it's not working for me on WSL. I don't know what that means with regard to whether it would work on actual Linux, which is what we were waiting to test. And if we didn't have LLVM as a dependency, we could test that very easily. But we have LLVM as a dependency, so it's incredible pain. Yeah, I'm just tired of all this internet snippiness. Like, it may seem like a hair trigger overreaction for me to do that, but I'm just like, Twitter culture breeds weaseliness or something. Like, I don't know how to say it. Like, it's just not, I can't deal with it anymore. It's too much. It's too much. Someone know if there's a reason we can't use the pre-built Linux binaries. Well, I sure tried downloading the pre-built Windows binaries, and that was part of my 3 days of pain. That was probably the entire first day of my 3 days of pain. So why would I expect that to work somewhere else? I will try to have a good night. I don't know where we're going to be at in the morning. I'm just envisioning another day or two of pain trying to get LLVM compiling. And then after all that, I find out that for some reason standard in is non-blocking on this laptop as well because the compiler is doing something that I can't figure out. Like, ugh. It works for you on real Linux. Yeah, well, I would expect that. So the question is, though, is it something WSL is doing? I kind of doubt it because nothing would work. Or is it something the compiler is doing, right? I don't know. I'm going to, I've had a good day. We did a lot of good stuff, so I'm not going to worry about it anymore. But I guess I'll wake up tomorrow and try to figure that out. Like, one thing that I could do, let me do this one thing as an experiment. On the WSL machine, if the very first thing from main is to do an fgetS, right? Then I could figure out if it's something we're doing, or I could binary search the program and see when fgetS stops working. All right, so let's see. Perhaps you should literally wait and try again. Well, I modified the thing so that it tries after every line, and it never succeeded out of hundreds of fgetS's. So, I mean, what do you want? Constant buff len is 100. fgetS buff len standard in. Okay. I've now made fgetS is like the first part of main. And it fails. It is literally the first thing that I call in main. Okay, let's put a while one around it. While one. If not result, if errno is equal to 11, continue. Do we ever is it something about like the console mode? Nope, it's just infinite looping. It's like, it's errno 11. I like wait and I wait. Programs can leak the settings, so you may need to reset it. Okay, what if I restart WSL completely? Ubuntu 18.04. Nope. It just fails. Wait, now it worked. Oh my God, you guys. Okay, hold on. Why did it work now? Oh, never mind. I didn't break other. Oh, jeez. Okay. I screwed up my while loop. I think it is somehow some other program set the console to non-blocking and it stayed that way. So is that it? I just had to restart the console? Let's see. I just had to restart the console and it works fine. Like the whole compiler works fine. Now I'm reverting all my stupid things that I just put in to try and debug this. Does actual Linux behave that way, or is it WSL only? WSL issues 4184. Whatever. Nobody's answering the bugs. Actual Linux leaked setting. What? It's the year 2021. What is going on? All right. So, hey, look, it works. Sort of. Yeah. Well, that was a wasted like 45 minutes of me being grumpy and whiny when in fact it's just computers being completely broken. And that is what it is. I suppose we could try to guard against that and set standard into blocking mode if somebody has set it to non-blocking mode. I don't know what I would have run that would have done that though. And why is that even a thing? But it works great. So I have the same crash here, and I've dropped into the debugger, and I can say where, and it gives me the stack. And yeah. I can actually keep running the program, interestingly enough. All right. So, I mean, I could make it so that you could poke values. We can do a lot of stuff in this debugger, honestly. All right, so I'm happy with that. It's been a successful day. We could ship this beta to people, and they would appreciate it. Yeah, I literally just had to exit WSL and restart it. And then it worked fine. You know there are beta users who definitely use the compiler through WSL. We'll see if anyone has this same problem. If they do, I probably... Don't you like FCMTL to FION bio? All these constants are nightmare constants from the 80s. FION BIO. Except we want the other one. This is non-blocking. FIO, file IO, non-blocking IO. I don't know why IO is in there twice. But okay. Ioctl. Where's the list of things? O non-block. I want O block. This is actually a pretty good typesetting for a man page. F control. Oh my God, dude. This is so terrible. Oh, wait. It's the other parameter controls it. I get you. I need to read carefully. Okay. Well, this doesn't really say. This just looks like a nightmare. Here's C code that checks a setting and warns. Wait. That's not good. He's saying what? Oh, flags and not. Okay. So you need to read the flags. Okay, we get the initial flags. Then we do. Okay, this is fine. So you say get flags, and then you say set flags with the new thing. Okay, that's fine. We'll put that in the file for tomorrow. Okay, we get rid of these. Well, we're just going to use this as a we're not going to paste this code, right? We're just going to use this as a reference. Anyway, thanks for looking that up. That'll be great. I have not used fcontrol in a very long time. They did a pretty good job 50 years ago that their stuff is still useful today. I mean, sort of. Part of it is the documentation is so terrible. Part of it is, I don't know, like, I mean, it's sort of true that it's cool that the same API sort of works, sort of still, but like, it actually would be better if we weren't doing that. I don't know. What was the reason for Linux to shorten the names of functions instead of something like file control? Because these functions are the same as were used in original Unix. They were being Unix compatible. And in the old days, they really didn't like typing and or it affected the rate at which your programs would compile because that's how slow computers were. And or the symbols in your debug build and all that. Like, weren't the green screen terminals 40 characters wide? I don't know. They might have been. We had some green screens when I was in college still, but they were probably more advanced. I don't remember how wide they were. Were they 40? Like VT100 style terminals. Back in the day, C identifiers could be 8 characters max. Yeah, that's probably part of it. I mean, when you look at the computers that people had in 1970, this all makes sense. Or even, you imagine someone who programs an operating system in 1970 has been programming for a while on computers from the 60s, right? The 60s is pretty early days. So, like, it makes sense, but it's just unreadable spam to me today, you know? If we update now, we'll end up with factory or factories. That's probably true. I would much rather have the traditional Unix API than factory factories by far. And I think it's important for modern programmers to have a similar level of knowledge of the history of computing in order to be effective, or at least have the right decision-making context. I don't think you need to know super much. But I don't know. Like, it does help. Like, if you know the history of computers a little bit, it does help with this understanding of how fast computers are today and how insane it is that we can't program them very well, right? I don't know. You would like more people to at least stop being so wrong about the history. How do you find that people are wrong typically? It just seems to me like people don't know. I don't find anyone saying things about the history of computers that were wrong. So I went over to Pop OS and the lock screen had come up, and when I pulled the lock screen down, it wasn't updating anymore. And I had to put in my password again and tell it to update. Or at least it wasn't visually updated. Maybe it's updating in the background. We'll see. I don't know, man. Or like carrying over the wrong lessons. Yeah. I mean, that's the thing is like, if people don't know how fast computers are, if they don't know how fast RAM is compared to the hard drive, if they don't know how much storage it takes RAM-wise to store the intermediate state of a compilation, because they can't visualize what the internals of a compiler might look like, well, then you could easily imagine them being wrong about that trade-off, right? I don't know, like internet arguments just don't seem to have a point to me. Yeah, Dragon Book. Dragon Book. Dragon Book. All right, everyone. Thanks for hanging out. We had a good time till that last bit. Let's see if there's people to raid. Who wants to be raided? Heartbound. Global Game Jam. We have not rated Lurk Zone in a long time. Wait, Is it actually Global Game Jam right now? I guess so. How is it day 2 of Global Game Jam and nobody is on Twitch doing it? Is Global Game Jam over? Does nobody care anymore? What's going on? Dead game. Is Global Game Jam the new PUBG? Is that what we're saying? All right. We're going to do Lurk Zone. Thanks, everyone, for coming by. See you later on. Maybe. Maybe.